The employee table holds all information regarding past and present employees. Its primary key is EMP ID with a foreign key, job ID. Other important information such as the employee's first and last name, phone number, and hire/fire date is located within this table. The employee table has a relationship with three other tables: order, job, and time entry. Data for the employee table is generated using randomdata.api.com. During our generation of data for our employee table, we ran into an issue involving the storage of photos within the database. While Xander created the employee generation script, I got to work on researching how to store images in MySQL and also how to get randomly generated photos for the employees. The photo generation script uses the Salium package to retrieve randomly generated employee photos. The package is used to interact with a website called thispersondoesnotexist.com, as recommended by Xander, which generates random images of people who do not exist based on certain attributes such as age range, gender, and race. Only function getEMP takes in three parameters: driver, birth date, and gender. The driver parameter is a current WebDriver instance, which is used to interact with the browser. The birth date and gender parameters are strings that represent the employee's birth date and gender. First, some checks are run to make sure the parameters are valid and the age range is then calculated. These parameters are used to select options from drop-down boxes located on the This Person Does Not Exist site to ensure semi-accurate images are generated for the employees. Due to the limitations of the site, an age range must be used to match the site's coding and capabilities. After selecting the options, the function waits for the image to load and retrieves the URL of the generated image. It uses another package, requests, to download the binary data for the photo, which is returned as a long blob. This blob can be placed in the database without the need for additional conversion, as MySQL supports long blobs. And here is Xander with the
Customer table.
customer table. Sorry about that.
Yeah, this is our customer table. This holds all of the data related to our customers who place orders for our products. And since our database schema is intended for use by an Intel plant, which manufactures and ships bulk quantities of Intel's chips, these customers would be generally retail stores or manufacturers of pre-made computers and whatnot. And so you'll see each customer has contact information and a delivery address, which are all, of course, randomly generated using the scripts that we made to populate our database. They have a join date. They have their IDs, and other than that, it's generally pretty simple. We also have our order table.
Am I going to the order table now or the job?
Yeah, to order. So these are the orders that customers place. You can see it as the order ID for keeping track of each individual order, the customer that placed it, the employee that served that order, which are all sales representatives, the date that it was placed, the date that it was shipped, which is just the next business day if that was placed on a weekend. Otherwise, it's same day delivery. The tracking number, which we had to generate, and also the order complete status, which is 1 if the order has been received at the destination and signed for, or it's 0 if the order has not been received yet, which only happens generally for orders placed within the past 2 weeks.
Okay, now we're gonna do the job table.
The job table was found using a database on the Intel website with a list of all their jobs positions. It includes a job ID in order to link it with the employee table, job title, and a job salary. All of this was just manually inputted, and we handpicked the correct amount of jobs and specific amount of jobs in order to operate our business.
Okay.
Here is the
What?
partner table.
Okay, yeah. For the partner table, when a customer joins, It will assign them to the employee with the least current customers that works as a sales account manager. And if the employee is promoted or fired, the customer will be reassigned to another employee with the least current customers. And the information that is kept is when the partner is assigned, the customer ID, the employee ID, and the partner ID. Now, which table are we going to?
Product order.
Okay, so for the product table, we just went to the Intel website and manually inputted the data found under data sheets. So all the stuff you think of that we kind of hard coded. That's it.
All right, which table next?
Next is order item.
Right. So order item table. This is using kind of pre-existing information since if you look at its attributes, it consists of like order ID, product ID, and then the price, right? So yeah, that's just created from the existing information that we already have, right?
All right. For the time entry table, I made the script to generate the data, and it generates day by day, from the earliest hire date to the current day, and every day it will check which employees are able to work on that day, and it inserts them to the table as long as the day is not a weekend or a holiday. And now I think we're gonna do Xander's screen share, right?
For the queries and triggers, yeah.
Yes.
Okay, so let me get my screen here. That's my camera. Here, share my screen here. Okay, so we're gonna step through each of the different queries and triggers here just sequentially. Is it good? Do you have it?
Yes.
Is it captured? Okay, cool. So the first query is a report that uses a join. So what we're going to do is we're going to get the customer data, and we're going to show for each customer, we're going to show their data, and then also the min, max, and average of their order price. Let me fix the. It's all right. So we're gonna run this real quick, and you'll see we have the customer data here, their minimum order price, max order price, and their average order price. So you can see customers like this guy here. He orders a lot more on average than someone like than this guy here. So the next one that's not only the report that uses a join, but that's also the query that uses a subquery. So then next we're going to have a query that creates a view.
Wait.
So here we're going to make a view for our unfulfilled orders, which is just any order that is not complete. Sorry.
If you want to
Yeah,
share
got that.
something, I'm just saying the quality is a little bit low, so you actually have to like read it out loud.
Gotcha. So I can zoom in. Does that help?
Yeah, that does, but the table still is blurry. So if you want to read
Gotcha,
anything from the
okay.
table.
Should I redo the last query then?
No, that's fine. You can see that
All-
the cost was higher.
You can see that?
Yeah.
Okay, gotcha. So here we're going to create our unfulfilled orders. And then here we are going to see from all of those unfulfilled orders which ones are, or rather, we're just going to display their data, primarily the tracking number and whether they're complete or not, which all of these should be incomplete. And we're going to sort them by date. So let me see if I can zoom in here. I don't think I can. You'll notice these are sorted by the least recent happening first in the table, because those would be the most urgent that we need to address immediately. And all of the tracking numbers are here for any employees to be able to manually double check on these orders and what they might be doing and to update them if need be. So next is the stored procedure that can be called by query to perform some math operation on the data. So what we're going to do is we can return the hours that each employee has been working this year. So we're going to select employee IDs and their hours worked this year. From wait, that should do it. Sorry, we have to pass in the employee ID to this function. So here we can see that pretty much all of our employees have worked around 574 hours this year so far. And so what this function is doing, hours worked this year, is it is from our time entry table, it sums the time but that they were in the morning and then after their lunch break, and then it converts that to seconds, then it sums it, and then it's does the other method. It needs to display hours, and then it filters out the results by year using the cur_date function and the time in that they entered the office in the morning, and returns all of this as a numeric value here. And then I believe the rest of these are Hezron. So if you want to share your screen, or I can do it as well. If you just want to talk about
Okay.
that. Hezron.
Yeah, you could continue. Yeah, if you believe this one also covers the same thing, possibly the store procedure that performs some math operations, right?
Mhm.
There's another one we also made called calculate order total cost, right? Is that right there?
Sorry.
Calculate order total cost.
Yeah,
Okay.
this one too.
So yeah, basically,
But this one is for a separate one. This one uses a cursor.
I just talked about calculate total cost, right? First.
First is the cursor.
Okay. The cursor one, we have update product prices. Basically, what this does is it will take an input, which you just say is a percentage. So the idea with this is that like inflation goes up, and so every once in a while, the price of all the products will go up by a percentage or two. And so what you can do is you just pass in the percentage as parameter, and using the cursor, it will grab the product IDs and the prices from product, and then we'll go through a loop and we'll just update all those product prices right there. Okay, and moving on. I believe we're moving on to triggers next, correct?
Yeah. So that was on the order table, right?
That is correct. I believe. Let me see.
Is it or oh no, it's order items. My bad.
Right. Yeah.
Yeah. Okay.
So
Close this one out. Use this one.
yes.
Here. So this guy.
Right. So for order item, we have two triggers. One is the after order item after inserts, and we have the order item after delete. So basically, the idea is that after we insert a new order item, that item has to be taken out of stock. So whatever the quantity of this item is, that quantity should be taken away from our stock. So that's what this one does right here. And then the delete one's kind of the opposite idea of that. So that if we get rid of an order item, say we inputted it by accident, or if they want to cancel that, then we'll put the quantity back in the stock that we have, right? And I believe now we can show an example, right? A little demo query to show that when we do update the order item table, that that the order stock, or sorry, that the product stock will be decreased.
So first we're going to show order items and products, so that we have a place of reference here. So we'll notice that here, this top product, product ID 0, it has 40,804 in stock. And so let's see, let's sort this by this ending. And our last one is 12,693. So we're going to insert the 12,694th order item on the most recent order ID as well for product 0 with 10,000 quantity and the same price as you can see in a table here. which, by the way, is there for historic accuracy in case our prices change due to inflation. So that's the reason for that redundant data. I don't know if we've covered that already. But anyway, so here are our order items, and here are our products. Fetch those again. And so we'll insert into here, and you'll notice that the product stock drops from 40,000 to 30,000 here. And we can see the new order right here with a quantity of 10,000. And so now what we're going to do is we're going to delete from order item where the order item ID is should be 0694. So here we go. And now we'll see that order item is gone now. And so it goes back from 30,000 back up to 40,000. So that is both all the demo queries. And I believe that's it actually. Now would be the short summary of the lessons that we've learned.
Well,
I guess. Oh yeah, if you want to go first.
I learned how
Go
to
ahead.
create scripts that generate data for MySQL tables and how to use cursors to insert them while in a Python script.
I learned a lot about Python scripts as well with their relation to MySQL, and just generally a lot of like database architectural design, and like how how a lot of the different tables interact with each other, the different constraints that you have to set, the foreign keys and whatnot, and just like generally keeping a good level of normalization and making sure that you don't have any excess redundant data that isn't there for historical purposes. Also, not to mention triggers and procedures, which are my personal favorites.
Austin or Hezron, do you want to go?
I
Austin.
learned a lot about using like random APIs in order to generate data, and like y'all were saying, using scripts in order to generate that data and input it into a database is something I haven't done before. So it was cool to learn about, and just learning about the different types that data types that MySQL supports and what other database supports, and what could have been more useful or more helpful during this project. Just all sorts of different things.
Ezra?
Yeah, so I would say definitely at the start of this project, in the beginning, definitely, it was another good practice of just getting to use normalization, go from 1F to 2F to 3F, and to just go over and trying to cross out any transitive or partial dependencies in the beginning and to make sure to match up all the foreign and primary keys. And then beyond that, as we started to go on, I would suppose like our team member was saying, the other functions and the procedures. That was fun, but also I would say just like intricacies with my SQL Workbench in general, such that like in the future, if I were to attempt something SQL related, I'd probably hit up my SQL Workbench because of this.